While programming, you've probably stumbled across a file full of curly braces, colons, and many levels of indentation. This cryptic structure is called a JSON file. It's one of the most widely used data formats in the world, and Python makes it incredibly easy to work with. In this video, we'll build a JSON file from scratch and learn to work with it in Python. For our example data, we're going to work with a product catalog for a small online tea shop. To store the catalog, we'll create a new JSON file called catalog.json. We'll start our JSON file with a pair of curly braces, which is called a JSON object. Inside those curly braces is where we'll store our data. In a JSON object, data is stored as key value pairs. The key is a label that identifies the data. For example, to identify the name of a product in the catalog, we could use the key name. Following the key, we write a colon. And after the colon, we write the value. For example, matcha. And just like that, we've created our first JSON object. But to make this a useful product entry, we need to add some more information like the product's price and whether or not the product is in stock. A JSON object can contain any number of key value pairs. We simply need to separate them with a comma. To add the product's price, we may want to use price as a key, followed by the numeric value representing the price. No quotes needed. Finally, the product's stock status is a yes or no question, so let's represent it with a Boolean. Note that, in JSON, Booleans are written as lowercase true or lowercase false. Great! We now have a complete product entry that is ready for any program to read. So before we add a second product to our catalog, let's see how we read our current JSON file in Python. To see both our code and the JSON file, we'll split the screen in two. The easiest way to work with JSON files in Python is to use the built-in JSON module. To read the file, let's create a context manager. To open, catalog.json in read mode. If you're unfamiliar with context managers, check out our video linked in the description. Inside the context manager, we load the catalog.json file into our program using the JSON module's load function. The load function reads our catalog.json file and converts its contents into a Python dictionary. To confirm, let's save the results into a variable catalog, print it, and run the code. Yep, that's a dictionary. Since catalog is a Python dictionary, we can access its fields by key using the usual dictionary syntax. For example, to output the product name, we specify the key name. We can do the same for price and in stock. The keys we use here must match exactly what's written in the JSON file. Running the cell, we get matcha, $12.99, and true. Note that the in-stock field is true with a capital T, while in the JSON file, we wrote true with a lowercase t. That's because the load function recognized the JSON Boolean and converted it to Python's Boolean type automatically. JSON and Python represent the same type slightly differently, and Python's load function handles that conversion for us. Awesome! At this point, we've described a product in a JSON file and read that file into Python. But as we saw before, our tea shop has more than one product. It also sells black tea. However, right now, our catalog.json file is built around a single product. To represent multiple products, we need to restructure the file to include a JSON array. To simplify our explanation of arrays, we'll clear out the matcha fields for now and add them back in a moment. JSON arrays are similar to Python lists, and they even use the same square bracket syntax. A JSON array is itself a value, which means it must be assigned to a key in the outer JSON object. Since the array we're creating will hold products, we'll use the key products. Inside the array, we can include any number of JSON objects. For example, to represent matcha, we add back those fields inside the nested object. Similarly, to represent black tea, we add the corresponding fields. Awesome! Now we have a proper product catalog containing multiple products, all stored in one structured file. To read this new structure into Python, we'll need to update our code. First, let's simply print the data under the products key to get an idea of what we're working with. Since this output is a bit hard to read, we can improve the formatting using the pprint module's pprint function, specifying the maximum line width. Running the cell again, we can now clearly see that the value of the products key is a list of dictionaries. As a result, we can access the items by indexing products, just like we'd index any other list. For example, to access the first product, we use index 0. From there, we can access any of the product's fields by key. For example, to access the name, we look up its name field. And just like that, we can pull any field from any product. Once the JSON is loaded, we're just working with a regular Python list of Python dictionaries. Everything we already know about lists and dictionaries applies. Awesome, these fields are a great starting point. But our tea shop is now looking to discount matcha. To add the sale price for matcha, we simply add a new sale price key and assign it to the value $8.99. But how should we handle black tea if we don't want to put it on sale? If we leave out the sale price key, our two JSON objects no longer share the same structure. While this isn't a JSON error, it can cause problems in Python. To see the problem, let's go back to the code and use a loop to try to print the sale price field of all the products. We won't need pprint anymore, so let's remove it from our code. When we run the code, we get a key error when trying to access black tea's sale price, since that field doesn't exist. Do we really want our program to crash in a situation like this? Probably not. To fix this, we have a few options. The first is to address the root of the problem back in the JSON file. To solve the issue here, we can make the object structure consistent by giving black tea a sale price field. But instead of assigning it a number, we assign it the special value null. Null is a JSON keyword that means a field exists but has no value. It's not 0, it's absent. In this context, it signals that black tea isn't on sale. Great, now both products share the same structure. Running the code, we no longer get a key error, since the sale price exists for both objects. In the output, notice that black tea's sale price is none, not null like we wrote in the JSON file. That's because the load function automatically converts JSON's null to Python's none. None is Python's equivalent to represent the absence of a value. So using null for a missing value is good practice, and it's the right fix when you own the JSON file your program is working with. But it's also quite common to work with JSON files you don't own. If you're requesting data from an external source, you can't guarantee that every field will be present on every object. To make our program robust against missing fields in JSON we don't own, we need a programmatic way to handle missing fields. The issue is that in our current code, we access the sale price directly using square bracket syntax. With this syntax, Python throws an error whenever a field doesn't exist. For our use case, this is not ideal. Luckily, there's a different way of accessing dictionary values that works better for our purpose: the get method. To use the get method, we replace the square brackets with the method call, passing in the key as an argument. When all keys are present, the get method works exactly like a direct key access. But if a key is missing, get returns none, the same as if the field were set to null in the JSON file. In situations like this, using get instead of direct key access is a form of defensive programming. Defensive programming is the principle that we should write code that is robust against imperfect data. Awesome! Now we know how to represent and safely read optional fields. Every field we've added so far only holds a single value, a string, a number, or null. But some product attributes, like the sizes each product comes in, can't be captured in a single value. To store multiple values under a single key, we can use the same structure we used for the products list, a JSON array. This JSON array contains strings that represent each size, instead of product objects. We do the same for black tea. This structure we've now created, an array of values, inside an object, inside another array, is called nesting. Nesting is what lets a single JSON file represent complex real-world data, a product with multiple sizes inside a catalog with multiple products. To access nested data, like matcha's sizes, in Python, we use indexing to access the product and get for safe key access. Running the cell, Python returns the sizes as a list. Great! At this point, we can load any JSON file and read any value from it using the list and dictionary tools we already know. But any changes we make to the dictionary, like adding a new size to the matcha sizes list, aren't automatically reflected in the JSON file. To make those changes permanent, we need to write the updated data back to the catalog.json file. To write back to catalog.json, we use a context manager to open the file in write mode. Inside the with statement, we use the JSON module's dump function to convert the Python's dictionary back to JSON. json.dump takes two required arguments, the Python object to save and the file object to write to. To make our catalog.json file readable, we also pass indent equals 2. This argument formats the output with 2 spaces of indentation per level, which keeps our JSON file human readable. To see if our code works, let's run the cell. Yep, it worked! The matcha sizes list now includes extra large. Awesome! With that, you can load a JSON file into Python, make changes using the list and dictionary tools you already know, and write those changes back to a disk, so they're there the next time the file is opened. If you want to practice what we've covered, the notebook linked below has exercises on everything we went through. We're working on lots more Python explainer videos like this one, so be sure to subscribe so that you don't miss out. If you have any questions or topics that you'd like to learn about, let us know in the comments below. We'd love to hear from you. Thanks for watching!